Projecting state diagram or UML from SBC process algebra. I'm Dr. William S. Chow. Chapter 1, SBC process algebra is a meta model or UML. We use this meta model to ensure consistency between UML so many different diagrams. Since SBC process algebra is a meta model or UML, therefore, state diagram can be projected from SBC process algebra. That is, state diagram will be a projected view of the SBC process of a system. Chapter 2 discusses what is SBC process algebra. SBC stands for Structural Behavior Correlations. SBC process algebra is the only language which is able to integrate the system structure and system to behavior all together. Since SBC process algebra is a language, we then describe its entities, its syntax, its semantics. Here, SBC process algebra has operational call or operational return formulas, and operational name, parameter list, and type 1 iteration, such and such, all are its entity of this language. We use an operational formula to describe an operation. There are two kinds of iteration in SBC process algebra. Type 1 iteration is an iteration between an actor and the COE object. And type 2 iteration is an iteration between the caller object and the COE object. SBC process algebra uses 3 Baker-Snell form rules to describe the syntax of the language. With the syntax of SBC process algebra, a system is then modeled as a many summation of IFDs. The first IFD is represented as G11 dot A12 dot A13 dot and the dot stop expression such and such. SBC process algebra uses the transition rule to describe the semantics of the language. Here we have the prefix transition rule. Also, we have the summation transitional rules. With the transition rule, we then get the transition graph of a system, as shown here. A transition graph is described by the transition relation T with 3 attributes. With further extension, the transition relation can be rewritten as T with 7 attributes. Now we have the summary of SBC process algebra. Actually, the transition graph will be the one and only single diagram that SBC process algebra used to describe the whole semantics of a system. Now, let's go to the final chapter. Chapter 3 discusses how to project a system state diagram from SBC process algebra. We say a system transition graph is described by the transition relation T with 7 attributes. In UML, a system state diagram is described by the transition relation SD with 3 attributes. And the projection algorithm has only one step. That's to select 3 attributes from T. Actually, that means we project 3 attributes from the relation T, which has 7 attributes. Thank you for your listening. Bye-bye.